So Hamilton is a pretty big company that has multiple business units within the life sciences space. Process analytics that you're looking at here today, we're very much embedded into upstream bioprocessing as well as downstream bioprocessing. And we're in the business of selling inline measurement solutions to help our customers improve their process understanding and control. Within the bioprocessing space, the need to measure inline measurements such as key performance indicators, things like viable cell density, total cell density, or dissolved gases such as CO2 and O2 are really crucial to achieving a reproducible bioprocess. And so Hamilton is in the business of providing inline measurement solutions that enable you to not only get that number, but be able to control off of that number. I have 3 products here that were all released within, say, the past few years from Hamilton. The first is what we call our Insight Arc. It's a viable cell density measurement that gives you inline biomass measurements of living cells only within your process. In addition to that one, we actually released a total cell density sensor based upon optical density to essentially measure in a very straightforward methodology the total amount of cells within a bioprocess. This one's really good for fermentation processes where typically you have a very quick turnaround in terms of, say, a 24-hour growth cycle from inoculation all the way to harvest. This gives you a very clear and easy measurement of inline biomass. And then the third measurement I have here is actually, it's an inline dissolved CO2 measurement system. So inline dissolved CO2 has historically been measured either using an older technology inline or using offline grab samples from things such as blood gas analyzers. The value proposition for this one is it's essentially a maintenance-free inline measurement of dissolved CO2 to not only get a number and get it continuously, but be able to do things like connect it to your mass flow controller or connect it to your head gas overlay to control those dissolved CO2 levels within customer desired measurement specs and be able to do it reproducibly. In the mammalian space or the animal cell culture space, cells operate very much within a defined CO2 range under normal metabolic conditions. Too high a CO2 concentration, and you essentially are either stunting the metabolic growth, potentially altering pH. In both cases, those things result in reduced growth attributes, which can translate to reduced product quality as well as product quantity. So CO2 is a measurement that is often understood and controlled to some specification, but not necessarily controlled at the bioreactor or production scale within defined sort of deadbands. So Hamilton is in the space of innovating the measurement solution. So applying, say, a novel technology, for instance, this uses non-dispersive mid-infrared. So it's essentially a novel measurement technique to get dissolved CO2 compared to, say, one of our competitors' measurements. That allows us to have, say, a different calibration routine. There's different drift specifications, different measurement tolerances to this. And then Hamilton's also in the business of providing transmitterless solutions in the sense that we have the sensor and then all the conversion units and the computation built into the sensor itself. This is it. This is the entire measurement solution. There's no transmitter, there's no secondary conversion. This sensor is a standalone that will connect and plug and play with any control system and most bioreactor platforms.